Good morning to everyone. That was John Coltrane. I don't know what the title of that was.
Bessie Blues.
Bessie Blues.
No one's name here is Bessie.
Okay. Okay. We wouldn't be blue about that at all. Let's see. We have a cartoon I thought we'd start with this morning from Peanuts. And the first panel. I'll never get this second problem. And the statement, just put down 11, Franklin. Don't worry about it. That's what I did. X is almost always 11, and Y is almost always 9. One thing I've learned about algebra, don't take it too seriously. So the fact that we have one of our problems on the test with an answer of 11, of course it was 11 and 13, but that's getting close. I've a homework set of papers that are going around. The way I graded these, you were allowed one error to get your 2. 2 errors took you to a 1.5. 3 errors took you to a 1. 4 or more errors took you to a half over 2. That was the lowest grade I gave. So that's the story on the homework. And we are into new material. We talked about it yesterday. The operational phrase today is square the first, square the last, and double the product. What is that for? There's a phrase that should go with. Square the first, square the last, double the product. A square of a binomial, and it is called a what? Trinomial perfect square. Okay, and then of course there's the idea of x minus y times x plus y. A sum times a difference, and you get the difference of the x plus y times x minus y would give you x squared minus y squared, so we would say the difference of the squares. And so that may help you at least remember what we were talking about yesterday. And of course the question, why would we, in a sense, memorize a particular rule? And it has to do with avoiding doing something with the distributive property or with FOIL. So it's to save speed on this, and the particular reference I've been searching for a moment here, we'll put it in the document cam. Boy, that blue just doesn't lend itself. I don't know how I can get that any darker. Does that help? Maybe shade it like that. Anyway, the idea of x plus y quantity squared, x minus y quantity squared, and that is the pattern we're looking at. I'd like to go to the board and look at it in 2 different ways. So I'm just going to look at x plus y as an example instead of a and b, but let's look at this expression, x plus y, and I'm going to go ahead and square this binomial. If I think of it as a distributive property, then I could take x plus y times the x plus y times the y. Now that's certainly making more work out of it than needs to be. And I hope you understand that whether I have the x on the right side or the left side, I'm going to distribute it through both parts. So I have x to the second plus xy. And then here, distributing the y through both sides, both parts, both terms, I guess is the better way of saying it, I get this expression. So I certainly have the square of x, the square of y. That's fairly obvious. And of course what you need to see is that you have 1xy, giving you 2xy. Hence the statement, double the product. Now that's sort of a pattern. And if I use x plus y, it's very typical. Oftentimes you'll see this as a plus b. So in the same way, let me look at it now with a minus b times a minus b, rather than x's and y's, just to change the pace a little bit. If I do this with FOIL this time, okay, so FOIL is going to be first, so that's going to be a squared. Then I'm going to do outers, and that's going to be negative ab. Then I'm going to do inters, or the center of the inners. Inner and center is inters. And so that's going to be an AB also alphabetically, so another minus AB. And then the last. So this is your outer and the inner. And we have FOIL. But the point being, you get the same result as if we did what? Use the distributive property. So this is A squared. We have negative 1AB, negative 1AB. That's negative 2AB plus your B squared. So whether you're doing it with X's and Y's or A's and B's, still the same idea. But it's a pattern I want you to see, because I'm going to mix the problem just a little bit. I'm going to make it more interesting. Let's say I gave you 3R plus 2S times 3R plus 2S. Now what I'm expecting you to see is that I'm squaring a binomial. That should be clear. Now the part that you want to look at says take the first and square it. That's 3R. So it might be worthwhile to put that in parentheses and then say square it. In the same way, down here at the end, I'm going to have 2S, and you're going to what? Square it. Now, what am I going to have in the center? Plus, you have to watch that sign. If it's a sum, you will have plus. If it's a difference, you'll have a negative. So I have plus what? Twice the product, and the product is 2S times 3R. Now that's looking at the pattern. This is your 2AB. And I messed that up to the extent I should have had my 3R first if I'm going to keep that consistent with the pattern. So perhaps if I replace those consistently, here is your A, here is your B. It doesn't matter because of commutativity. But if we look at that, that would be an intermediate step. That's an important substitution I just did there. Okay, so I'm thinking of the pattern A plus B or A minus B quantity squared. And what I'm thinking now is I replace A with 3R and B with 2S. Do that as an intermediate step. Now what is your result going to be? 9R squared plus 12RS plus 4S squared. And again, the problem, you've got to remember to square both the 2 and the S. Now that's a little bit more complicated than X plus Y quantity squared. But it's the same principle. Now again, what we're trying to do is save some time. You could use FOIL. You could use the distributive property. But if you have the pattern recognized, you can get the answer quickly and save yourself some difficulty. Now I'm going to reverse this process for a moment. I'm going to give you the trinomial perfect square, and I want you to tell me what squared binomial was involved. You understand the question? I'm going to give you the answer to the question. You tell me what the question was. This should be fun. 4x squared, 9y squared, and I have in the center 12xy. That is my answer to a problem in which you squared a binomial. Will you write on your paper the binomial product that was involved before anyone says what the answer should be? Working backwards, you tell me what I multiplied to get that answer. If you can, you really have this. If you can't, you need to think the pattern a little more carefully. So I'll give you a little bit more time. And some of the questions you're going to ask: is the first term of that trinomial a perfect square? Is 4x squared a perfect square? What is it a perfect square I don't want to say it that way, of what term is it a perfect square? 2x. So you recognize this as 2x quantity squared. When you see 9y squared, I hope you are not seeing 9y squared, but you see instead 3y quantity squared. Is the middle term correct, given what you've recognized as the first and third terms? Is this, in essence, 2 times 2x plus 3y? Does it fit? If it does, then what can you say is involved for these two binomials? I hope you saw this, which you could rewrite as this. Now, if you were successful seeing that, that's an important thing to see, because this working backwards has a special name. Factoring, working backwards. So if you recognize the products, you can go backwards. And that is a very important process. Okay. At this point, I have absolutely no sense of whether or not most of you are following what I just did. Okay. Poker-faced and all. Let me try one more in this way. We'll see if we can do better in this one. You won't, I promise. Okay, 25b squared. In fact, will somebody tell me what I need in here to write my answer so I can ask the question? Does somebody see what has to be there? Okay. Which is? Two times 7 times 5. 2 times 5 is 10, and 7 times 10 is 70. Okay, good. Now, can you tell me, knowing that, what goes in here? (7a) minus 5b, and then again, 7a minus 5b. Does it work? Square the first is 49a squared. Square the last, 25b squared. Let's take the inners and the outers. Negative 35, negative 35, that's negative 70ab. We've got it. We're in business. So I want you to either be able to go this way or that way. Start with one, get the other. That's your goal. In the same way, when you learn multiplication tables and somebody said 5 times 7 is 35, now memorize it. Then if somebody said 35, what were you supposed to see in reverse? 5 times 7. You're not learning one thing, you're learning two things. You need to be aware of that while we're doing it. Okay, let's go to the next special case. The next special case, a minus b times a plus b. Does it matter which one is first, as long as I have the signs opposite? No. I could say a plus b times a minus b. But notice what happens to the outers and the inners. Sort of a happy face there. The outers and the inners. The outers, ab. The inners, negative ab. They go to a 0. So all you have is the difference of the squares. Okay? So we need to look at a little more interesting problem, such as (4x plus 3y times 4x minus 3y Now what you're supposed to see is that two binomials are only different in the sign. Both of them have 4x and 3y. So one is the sum, one is the difference. So I'm going to take the difference of the squares. 4x squared is 16x squared. But I'm going to write it this way first, because it's this general pattern that's involved here. And now, of course, 4x quantity squared is 16x squared. The 3y quantity squared is 9y squared. So we know this is going to be 16x squared minus 9y squared. Any problems with that? Now what I'd like to do is give you the answer, and you again tell me the problem. So my answer this time is going to be 81a squared minus 64b squared. Okay, so I've given you a problem, and these terms I gave you the answer to a problem. I'd like you to tell me what the original question was. Write it down first, please. So you have written on the board 81a squared minus 64b squared. You shouldn't see what I wrote. What should you see? I hope you see 9a squared minus what? 8b squared? Because if you saw those two squares, you know the answer. The answer, 9a. Now, which do you prefer, the plus or the minus first? The plus. Some of you do, at least. And you're there. Nearly there. Okay, so 9a plus 8b, 9a minus ab. And you've got it. The big thing here is to see patterns. Now let's carry this a step further, and Debbie, I'm going to have to travel to the side very soon here. Squaring's fun, but cubing's more fun. If you love squaring, you'll love cubing. And then you can do quadrupling and quintupling. Okay. I'm going to go to the book first. Just follow me maybe with the pan here for a moment, and we'll go to the book. The original problem that's related to this question that I'm going to address is found in your book as we go to page 252. And this is where you have things like m minus 5 quantity to the third power. That's number 47. And then we have a later problem, as I just scoot over, 3r minus 2t to the fourth power. That's not going to be fun. But we're going to look at it anyway. Now, let's come off there for a moment. Let's see if I can get something under here, Debbie, to keep the book propped up where I'd like it. And let's come back to the m minus 5, and I'll just let you zone in on that. Okay, we want to look at the idea of cubing something. And the question is, what do you do? And I'm not going to do that problem yet. I'm going to do a minus b to the third first. And then what will I focus on? Substitution. So I'm going to do the one problem, see the pattern, and use it. What is being suggested in the book is that you see a minus b to the third is a minus b to the second times a minus b. But you know what a minus b to the second is, because that's our shortcut, which is square the first, double the product, square the last, and then do what? Multiply that mass by a minus b. Are we ready? You understand what I did there? We used what we knew to get something more. Well, the a now I'm going to distribute over everything, so that's a to the third minus 2a to the second b plus ab to the second. Now that was taking a times everything in the trinomial. Then I take minus a squared b minus 2ab squared minus b to the third. Do you see what I did with the b? The b came times the a, and I had a negative sign, so negative a squared b. Then I had the b times the 2ab, which gave me negative 2ab squared. Then I had the b times, the negative b times the b squared, hence negative b cubed. We okay there? Yes? Okay, this was a, right? But that's a positive a times a negative 2a, which is negative 2a squared b. The next one. Bump, 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 over here. And yes, it should. Thank you, Jennifer. So I should have 2ab squared. Yes, to get the sign. Thank you. Now are we ready to combine? We only have one term with a cubed, so that's okay. A to the third. Now I have a couple terms with what? A squared b. Here's one, here's one. Negative 3a squared b. Technically that's to the first, just for the heck of it. That'll be nice to see. Now, do I have an ab squared? Here's an ab squared, and here's the one I needed with the plus sign, and that's going to give me 3a to the first b squared. Then a minus what? B to the third. Now that may not seem particularly interesting, but do you see how the exponents on the a go down one at a time while the exponents on the b go up one at a time? We started with what? A to the third went to what? A to the second went to a to the first, and then technically here is a to the 0. A to the 0 is 1. Okay, let's look at the first term. B to the 0, because you don't see b, it's b to the 0. Then b to the first, b to the second, b to the third. Sort of up the down staircase, so one's going down while the other's coming up. The rains come down as the floods go up. You've all seen that. Rains come down, floods go up. No. Okay. Notice the sign here did what? It went from, it was a negative, and we went plus, minus, plus, minus. Sort of a checkerboard of pluses and minuses. Okay, back to the document cam, please. I had a 3m minus 1, correct? And I was cubing it. That's what it says. So what is A and what is B? Here's my pattern. A is 3m. B is 1. So what does it tell me to do with the A? Cube it. 3m to the A cubed. A is 3m. So 3m to the third. Minus what? 3 times A, but A is what? 3m. A squared. B, which is 1. Plus 3 times 3m times 1 to the second minus 1 to the third. Pardon? I didn't hear the question. You said something about top to bottom.
No, I was just saying that I was confused. I thought we were going to start like how we did last time.
Nope.
Right into the problem.
You got it. I used the pattern that I saw for A minus B to the third, and I realized this is 3m minus 1 to the third. So if A is 3m and B is 1, I could just substitute into here. Okay, what's 3m to the third? 27m cubed. Okay, next one. Now we have 3m to the second, which is 9m squared, times 3, which is negative 27m to the second, plus 9m minus 1. Done. Agree with the 1 to the third?
I was cubing the 3.
Ah, yeah, you would in the first, but we have the 27 there.
But 1 is cubed, so.
Right, and 1 cubed is 1. Now, what's your alternative if you don't want to do it that way? You say instead that you have 3m minus 1 squared times 3m minus 1. What's that going to be? Well, that's going to be 9m squared. Tell me what the product is. Squaring this binomial. 9m squared plus 1's at the end. Oh, we're in trouble. Debbie, where you have a squared minus 2ab plus b squared underneath the clock, where I started with a minus b times a minus b. Can we go back to that on the front board with the camera? Yes, please. That panel right there, that portion. Now notice, if you have a minus b times a minus b, you're supposed to get what? A squared minus 2ab plus b squared. You square the first, square the last, and take twice the product. Now let's go back to what I had with the first camera. You have 3m minus 1 times 3m minus 1. That's what 3m minus 1, quantity squared, represents. So this portion right here is 3m minus 1 times 3m minus 1. You have to see this as a product. Now let me ask my question. What is 3m minus 1 squared going to give you? 9m squared, the plus 1, and what's the middle term? 6m. Twice the product. 1 times 3 is 3, double it is 6, so that's negative 6m. Are we getting that? I hope. You memorize a product. A minus b. Square the first, square the last. Now take the product of 1 and 3. That's 6 and 3. Double it and you get 6. The pattern. Otherwise you're back to what every time? Foiling it. Foil's good, but it's... Foil is walking and this is running, and I want you to be able to run with it and see the pattern. The pattern is what you're going to build on. But I still have this multiplied by what now? Another 3m minus 1, because I had 3m minus 1 to the third. So I guess I'll rewrite this down here, and we'll sort of work our way up. 3m minus 1 to the third means 3m minus 1 times 3m minus 1 times 3m minus 1, which is the square then of a binomial times it again. So what am I going to have to do now? Take each part of this and multiply it times this. Okay, are we ready? 3m times 9m squared. 27m cubed. Okay, 3m times minus 6m. Negative 18m squared. 3m times 1 plus 3m. Okay, now the negative 1 times 9m squared, which is negative 9m squared. Notice how I'm lining things up. Negative 1 times negative 6m. Plus 6m. Negative 1 times negative 1. Negative 1 times positive 1. I didn't say that right. Negative 1. Okay. Add all this up. So we have 27m to the third. Negative 27m squared. Plus 9m. Minus 1. Will you compare? Okay, Debbie, let's take camera 1 and get the 27m cubed on that first answer, and we'll just switch back and forth. Yes, please. More or less at the bottom of there, whatever you can pick up. So I'm going to have Debbie show what we had on our first answer and to our second answer. First answer. Feel like an optometrist? Okay, go to the second answer. Do you see the same thing, I hope? If you did, two different ways of doing the problem. Let's go back to the book. Document camp. That was 3m minus 1 quantity cubed. So what did I ask you to see instead? A minus b quantity to the third. Okay, let's come off there when you're ready, Debbie, and we're going to look then at the next one. Okay, we're going to look at 49 and 52. What would I expect you to see in 52? Instead of 2z plus 5y to the fourth, what are we going to see first? A plus b to the fourth. Bless you squared. A plus b to the fourth. Then a is 2z, b is 5y. So I'm going to do a plus b to the fourth first. So let's come off there for just a moment. Now this idea of seeing patterns is very important for your future health. Back to the document camp. You understand we're doing this so you'll be healthy. You probably aren't buying that. So I want a plus b to the fourth power. Okay. There are a couple ways we could do this. We could say, this is a plus b to the third times a plus b, correct? We agreed? See that? Or you could see a plus b to the second times a plus b to the second. Now the last one in some ways is a little bit easier because you know how to square a binomial at this point. A plus b to the second is what? Square the first, square the last, double the product. Aha! And the next one is the same as the first one. A to the second plus 2ab plus b squared. Not all that fun, but we could do that. Or, okay, Debbie, camera number 1 on the first panel where I have 4 lines down. A to the third minus 3a to the second, b to the first plus 3a to the first, b to the second plus, or minus b cubed. Now, my question. If these had all been plus signs instead of negative signs, would you be comfortable with saying all these would be positives? Again, might help to watch the screens. If this had been a plus b, that each of these signs would be positive. Okay, so I'm going to take that idea. So I could argue this is a to the third plus 3a to the second, b to the first plus 3a to the first, b to the second, plus b to the third times a plus b. Now, I was cheating. I was using a pattern. Okay, I was saying a to the third, then goes to a to the second, and then it goes a to the first while the b's go up. The only secret I haven't shared with you is how did I know this was a 3 and this was a 3? Well, we just did it, but that was not the secret. I'll share the secret shortly. Now, I'm going to write what I believe is the correct answer without doing any multiplication. Fair enough? I know it has to start with a to the fourth, and I know the a's have to go down. So I know it's going to have to be a to the fourth, and this is plus signs all the way, so I don't have to worry about anything else there. Then I know this is going to go a to the third when this is going to go b to the first. Because as the a's go down, the b's go up. As the rains come down, the floods come up. Okay, plus a to the second, b to the second, plus a to the first, b to the third, plus b to the fourth. That's the pattern. Now here I knew it was 1, 3, 3, 1. 1 a to the third, 3 here, and 1 b to the third. This is going to start with the 1, 4, 6, 4, 1, and I'm done. Well, let's see if we're right. Wouldn't want to spoil the thunder here. Are we ready? We got to take a times all this and b times all this and add them up. And maybe we'll get this if I'm lucky. You aren't nearly as excited about this as I'm feeling. I mean, this is goosebump time. Okay, a times a to the third is a to the fourth. Then a times 3a squared b is going to give you 3a to the third, b to the first. Then a times this will give you 3a to the second, b to the second. And then a, b to the third. I just took a times all the garbage and wrote it down. Now I'm going to take b times all the garbage and write it down in the appropriate columns. So b times a cubed is what? A cubed b. By the way, note, thank you, Debbie, I have a cubed b and 3a cubed b. That's 4a cubed b. Life's good. Now what? B times 3a squared b, which is going to give you plus 3a squared b squared. And guess what? 6. That worked. B times what? 3ab squared, so that is plus 3ab cubed. And that gives you 4 of them. Plus b to the fourth. I'm done, and it worked. Now my question, let's go back to the document, Camp. I was supposed to take what? 2z minus plus 5y to the what? The fourth. A is 2z. B is 5y. And I know what a plus b to the fourth is. Let me write it out again. I know this should be if a is 2z and b is 5y. Remember again, it's a to the fourth plus 4. A to the third, b to the first, plus 6. A to the second, b to the second, plus 4. A to the first, b to the third, plus b to the fourth. If you know that, you can plug these values for that and be done and save yourself some time. So it says take a to the fourth. Well, that's going to be what? 2z to the fourth. Then 4, I need a plus sign there. That's looking awfully crowded, isn't it? Okay. I need more space. The a is this. The b is this. Now, a to the fourth. 2z to the fourth plus 4 times a to the third. That's 2z to the third, b to the first. So that's 5y. Plus 6a to the second, 2z to the second, b to the second, that's 5y to the second, plus 4a to the first, which is 2z to the first, b to the third, which is 5y to the third, plus 5y to the fourth. Okay? Are we ready? 2 to the fourth. 2 to the fourth. That's 2 times 2 times 2 times 2. 16. Z to the fourth. Okay, 2 to the third. 8 times 5, 40 times 4, 160. Z to the 3, y to the first. Okay, 2 squared, 5 squared. 4 times 25, 100 times 6, 600. Z to the second, y to the second. Having fun yet? Okay, good. 3 of you are. 2 times 5 cubed, 5 cubed, 5 to the third, 5 quarters. 125. 125 times 2, 250 times 4, 1,000. Z to the first, y to the third. Okay, 25 squared. Shortcut time. 2 times 3 is 6, and then put a 25 after it. We did it! Well, we worked it together. Now, what's the alternative if you don't want to use the pattern? Well, you can say this is 2z plus 5y to the second times 2z plus 5y to the second, which is, are you ready? Square the first, square the last, double the product. You act like you're sort of at the end of your rope. Okay, what's 2z quantity squared? 4z squared. Okay. We're into panic here, nearly. 5y squared it. 25y squared. Okay. 2z times 5, y times 2. Double the product. 20 yz. We'll take it alphabetical. There we go. So we have 4z squared plus 20yz plus 25y squared times 4z squared plus 20yz plus 25y squared. And do all that, and you're going to get what? 16z to the fourth plus 160z cubed y plus 600z squared y squared plus 1000z to the first, y to the third, plus 625y to the fourth. I need another wall. Okay, so we'll leave that for a moment. Let Debbie keep that on camera. The question, which I know you're just dying to ask, maybe, is the following as we come back. On camera 1, please. Whoa, the zoom is fun. Okay, we panned a bit. Let's see what we can do. I should have had you go to the book first and then that. I'm sorry, Debbie. Now, my question. What would you do? You wouldn't cry. Okay, good start. Good start. It's going to have to start with an a to the fifth, yes? It has to. And it has to end with a what? A b to the fifth. Just walk down the steps. Okay, let me try. Go ahead.
In the pattern where you show it going like 1, 4, right, 6, 4, 1, is that correct?
Yeah, 1, 4, 6, 4, 1. That's the pattern we're looking for after I get this first part. So before we go any further, let me write down what I just heard started, and let's see if that makes sense. I need to have that out just a little bit more. Okay, Debbie. That's what I heard. Start with a to the fifth. The next one has to go down to what? A to the fourth, b to the first. Then what has to happen? It's going to have to go a to the third, b to the second. Then it's going to have to do what? A to the second, b to the first, to the third. Sorry, go up one. I was going the wrong way. Plus, drop the a down to the first. The b goes to the fourth. Then b to the fifth. You know you're going to get 1 there, sliding over, a 1 to start. Hint, if this is going to be a 5, then this is always going to be a 5, the next one. In the same way, the last one's going to be what? A 5. So the question is, what goes in between? Okay, let's come off there for a moment. We're looking for patterns. Looking for patterns. I'm going to have to write something down on paper for you because I've run out of board. And as you see what I'm doing here, you'll know the answer for what I just asked. Okay, here are some problems. A plus b to the first, a plus b to the second, a plus b to the third, a plus b to the fourth. Now let's see what we get out of this. Let's come off there for a moment. I'm going to write some more numbers. And it'll just take me a moment, but it's necessary that I write this out first. Okay, here's the first two. 1a plus 1b. I guess I should try to pull that up a little bit. Debbie, let's come off just for a moment so you can see what I'm trying to do. There we go. Do we agree so far? Now, you aren't probably inclined to take 1 times a squared and 1 times b squared, but it helps. Now, Debbie, I need your help. I need camera 2 to go on the first panel on the left side where I had a minus b to the third power. So we're going to come to there, and I'm going to ask you to cut to that first panel where we had a cubed minus 3a squared b. You got it? Okay, look at the monitor because Debbie has a minus b to the third. Now, the only difference is I'm doing a plus b. But while you're looking at that, I'm going to take a moment to write what you're seeing on the board and then ask Debbie to come back to the document cam. There's that same result. So I have 1, 3, 3, 1. What I'm doing is looking at the coefficients. Okay? Now, Debbie, camera 1, to the far end where I have a to the fourth plus the far right, top line, far right panel. You aren't far enough to the right. Way over here. Are you there? Oh, I see. You're doing there. Okay, gotcha. Okay, can you bring that in a little bit tighter? Okay, now what you're looking at, I'm going to write down while you're looking at it. And then we will come back to the document cam. Okay, just a minute, Debbie. I need to see if I can. Okay, let's try it now. That's what you were just looking at. Now, I'm going to try to drop this down just a little bit and tighten it up. Okay? Now the only thing you don't see is a plus b to the 0. And I'm going to put that up on top, so let's come now back to me. I'm going to put a 1 up here, and then I'm going to come back to the document cam, and what I'm going to ask you to note, look at the coefficients. First row is a 1, next row 1, 1, next row 1, 2, 1, next row 1, 3, 3, 1, 1, 4, 6, 4, 1. I'm going to write down what I just rattled off. So let's come off there. And I'm going to write a 1, a 1, 1, a 1, 2, 1, a 1, 3, 3, 1, a 1, 4, 6, 4, 1. And welcome to my triangle. Do you see anything? I hope you do. Let's see. 3 and 3 is 6. 3 and 1, 4. 1 and 3 is 4. 2 and 1 is 3. 1 and 2 is 3. Okay, next row time. What's my next row? 4. That's a 5, right? That's a 10. That's a 10. That's a 5. Fill in some 1s. And now, what this tells me, 1a to the 5th plus 5a to the 4th, b to the 1st, plus 10a to the 3rd, b to the 2nd, plus 10a to the 2nd, b to the 3rd, plus 5a to the 1st, b to the 4th, plus 1b to the 5th. I need to bring that up just a little bit. See if it will keep from dropping down. Let's come off there just for a moment, Debbie. I need to pull that up just a little bit higher. Okay, let's try it. Now, I know that's not the most readable in the world, and I need to slide that down just a hair. There we go. That's neat. Now, I don't expect you to be able to do that quickly at the moment, but I want you to recognize what algebra is about. Okay. Patterns. That particular result you just saw is named Pascal's triangle. I don't go around memorizing products very often, but this is one that you need to know. And it's all the way through mathematics, and there's no reason why it has to be delayed to Math 90, where it typically is taught. But it's what makes doing some of these problems not so hard. And if you can see this and use it now, it's one huge benefit. You don't have to do this, and you aren't going to see very many problems like the problems that we just talked about on page 252, problems 50, I guess it was 52, 51. Those are extreme. That is asking you to walk on water right now. But it's not a bad goal. If we look, Debbie, with camera 2 now, at the right side of the front board as you're looking at it. Front board, right side as you look at it. And let's come back over and look at 7a minus 5b. Here's the product. This product right here. I hope now, after what I've just put you through, you look at this and say, that's not bad at all. 7a minus 5b times 7a minus 5b, you're just going to do what? Square the first, 49a squared. Square the last for 25b squared. Take the product of the two and double it to get 70. Remember the sign, and you're there. Bottom line this morning, you have to be able to do something like this without really getting too upset, and this down here the same way. 4x plus 3y times 4x minus 3y. Right now, that should just hit you as 16x squared minus 9y squared, and you're done. That fast. That's where I want you to be. The next level of expectation on my part is that I can give you a trinomial and you can see the binomials involved. If I give you 16x squared minus 9y squared, you see this. If you can do that part, you're at the level I want you today. Now, if you can go the extra mile, and let's drop back to the document camp. If you can see that, then you are awesome today. You are really walking on water, and that's good. You don't need to know that today. You don't need to know that tomorrow. But if you do, life's easier. It's worth the challenge. Your homework is, of course, the 1 through the 54 odds. Well, let's see. Does that make sense? I'd better back off on that. Let's back off a little bit there because I haven't told you the shortcut about 50 times 49 and that kind of thing. So let's just take 1 through 30 all. 1 through 30 all, and then tomorrow I'll just briefly talk about some of the other things. 1 through 30 all, and let's throw in one problem for the fun of it, 51. So 1 through 30 all, and then number 51. And boy, I look fuzzy as heck on that monitor up there. I hope I'm not coming across simulcast that way. Okay. And that I'm looking okay there. So, Debbie, with that, we're going to go back to John Coltrane, I assume, and what is your choice?
Love Supreme, Pattern.
Oh, yes, my kind of song. Have a great day.